All right, I'm back. Next up, we have Jared from Compound Labs.
Hi, hello. Thanks everybody for having me. I'm Jared from Compound. I guess that was a great talk by Kurt. I'm actually going to talk about a lot of the same things, um, but I think I had too much content, so great that I can just focus on some of the differences here. But yeah, I want to talk about more like Compound's approach, my approach to thinking about protocols. I've been at Compound for almost 4 years. Worked on the design and shipping V2 and all the things we've done since that. V2 is the current Compound protocol on Ethereum. It's yeah, I mean it's a little over 3 years old as well. And we just actually like 2 days ago released or launched V3, went live. We actually deployed it a few weeks ago, but the governance proposal to make it active just went live a couple days ago. So I'll talk a little bit about that as well, but really wanted to just talk about kind of our approach um, like security through design and the design process. And yeah, I mean, really picking up where Kurt left off about how the practices and the process that you have can lead to, it's not about doing one specific thing. It's about defense in depth and having a lot, just good principles, good guiding principles that, make sure that you have a safe protocol. So how should I do this? Scroll down. Okay. Is this? Oh, here we go. Okay. So yeah, it can be pretty daunting to ship code to mainnet or any blockchain. It's more like shipping hardware or launching a satellite. There's less that you can do once your code is out there to mitigate any issues. Things just take more time, especially have a DAO or a time lock or something that prevents you from making upgrades immediately. It's just you have to put more effort and investment in upfront to prevent issues. A lot of what was just talked about. So the way I personally like to think about the process is really like 4 steps. So it's like the specking step, the code step, the test step, and the ship step. These aren't necessarily sequential. So I think really it's like a diamond almost. The first thing is to spec, which I'll get into detail on all these things, and then you can do coding and actually these kind of coding and testing in parallel, and then shipping is when you're finally done with everything. But yeah, I think at Compound, and something that I'm a big believer in is the specking process and how important it is to write a good spec up front and get all of your kind of design considerations and really have like a complete protocol on paper at a high level first before you start to rewrite that at a lower level. So the things that you should be thinking about when you're writing a spec, in my opinion, are what are your goals, what are your use cases, what are not your use cases. Something we'll talk more about later, or like what invariants must hold. For Compound, it's always safety first. So the fundamental accounting equation, assets equals liabilities, always has to hold. In the case of Compound, this is generally like supply plus reserves equals cash plus borrows. It's a high level invariant that should just always be true, and you can test this with formal verification and other methods, but it's kind of it's non-negotiable. And then there's other attributes that are desirable that help you make decisions when you're not sure what else to do in the spec, because I think the spec writing process is also just the process of making lots and lots of decisions, exploring a huge decision space in this design space that you're in, and trying to figure out what to do. So yeah, what attributes are desirable for Compound 3, for example? We had there were some things that we wanted to do differently from V2. One was focus on efficiency, so both capital efficiency and gas efficiency. So this helps when you're writing a spec to really. I can try. So how's that? Okay, great. Yeah, so efficiency another focus for Compound 3 was the ability to make it more portable and deployable on other chains. So we tried to really fit a lot into a single contract. Did away with our like hub and spoke model for V2, where there's like a market, a contract for each token, and then a central risk management contract. Really tried to pack a whole market into a single contract, and this that guides a lot of decisions as well. And always the tiebreaker for making decisions is like what's going to be simple, better for users. The simpler the protocol is, the easier it is for people to understand and interact with, and just the better overall. So yeah, as I kind of alluded to, the spec writing process is kind of it's a decision making process. There's just an enormous design space for a protocol that without even specifying what type of protocol you're writing, it's a huge space to explore, and usually you shouldn't be working alone. You should be doing this with a group of people, and you want to do that. So you want to explore this space collectively, and you want to do it as exhaustively as possible, and you want to write down all these decisions that you're making, and hopefully some rationale as well for why you're making those decisions. But you only have limited information when you're trying to do this. So this is kind of one of the hard parts about this exercise is like how do you make decisions when you don't necessarily know what's going to be better for users or how things are going to play out or evolve. And so my advice here is to do what it takes to move the discourse forward when now. So I think Kurt talked about it, but modeling simulations are a really good exercise to help you gain insight into certain problems. For instance, in Compound 3, we knew that we wanted to change the liquidation mechanisms from V2, but we didn't know exactly what was the best alternative. So we did a lot of Monte Carlo simulations and modeling of the liquidation dynamics to try to figure out what would sort of be a better system that might not that wouldn't lose lots of funds for the protocol. It has, as mentioned, this is there's a lot of caveats when you're modeling things like this, but it does help you to make decisions earlier on when it's kind of the best tool that you have available. I think when it comes to speccing, the more you do it, like anything else, the better you'll get at it. With V3 of Compound, there's a lot of learnings and regrets from previous versions that we were able to incorporate into our spec. So that's always helpful. And just remember that the spec is like a high level design document, and it's so therefore it should be also the cheapest version of your protocol to iterate on. It should also be the easiest to collaborate on. If it's not, then you should use a different platform for writing it. We tend to use just like Google Docs, and where people can comment and collaborate in that way. But whatever your favorite collaboration tool for writing documents, I think that's what you should use. But if it really it is like a higher level version of your whatever protocol you're trying to write, and the next step will be to compile this down to code and a lower level code. And so, yeah, almost by definition, it should be just cheaper to iterate on. So, and if you've done it well, then the code and the tests should pretty much fall directly out of it. And so, this is kind of the hard part of building a protocol, in my opinion, is doing the specking and doing it well. But yeah, once you get to the code step, there's kind of, there shouldn't be too much to think about. You've already made all the hard decisions. If you find that you're debating what to do in the code, then you should probably go back and fix your spec. It should just be an exercise in really just like compiling your English or high level language into Solidity or whatever you're writing your protocol in your contracts. So yeah, it's kind of like coding is probably the easiest step. I also consider unit testing as part of the coding phase or step. As as Kurt also mentioned, unit test is kind of just like table stakes. You should have 100% unit test coverage of anything in your contracts. The best way to do that is to always keep your main development branch like completely covered, and you should only merge branches or pull requests once things are covered, and that means that unit tests you're writing them together with the code that you're implementing from your spec. All your branches that are in your code should be reflected in your spec. So, there should be at least one test for every branch in your code that should map to a unit test that should map to a coverage of your spec. And the best way to do this, in my opinion, is to write these together and do them one for one. And it's very straightforward. It's kind of like the most boring part of writing a protocol probably is, the spec is kind of like interesting and fun and design challenge. Now you're just like compiling in the coding phase, and then there's this other step of testing, which is the more like interesting, thoughtful kind of testing. Just moving along here. So, I guess what I wanted to kind of communicate or focus on here was that, first of all, think in terms of invariance. Kind of brought up one invariant earlier, the fundamental accounting equation. These invariants that you should have thought about during your spec process, you should try to write these down. So for compound, just some examples. There's the fundamental accounting equation I mentioned. There's exchange rate should always increase. So for V2, we had C tokens, and in C tokens there's an exchange rate between the token and the underlying asset, and this should never go down, basically. And that's an example of variant. Another type of variant might be like if you supply an asset supplied should always be able to be withdrawn by the user that supplied it, or an account that goes underwater should be liquidatable, for example. So these are just like statements about the protocol, about the state that should always that are just true. The thing that trying to avoid here is writing more imperative steps that you would have been writing in like unit tests, where you say like, okay, user A initiates supply of whatever X amount of some asset and then withdraws it, and that tests a very specific situation, but doesn't tell you like what the higher level property of your protocol should be. Another example about creating a borrower and the prices move against them, and then you liquidate them. That's like one specific thing that you're testing, but it's not a general property that lets you generate lots of test cases or prove it in a formal way. So focus on invariance. Start with the strongest invariance, the most global, absolutely true invariance that you can claim, that you'd like to claim. Doesn't matter if you can prove these things or not yet. The step after this is to figure out strategies for proving these things or getting at them. But first of all, think about what they are, write them down, uncover implicit assumptions that you're making about your protocol, preconditions. Make everything explicit as best as you can. So that's if I guess if there's one takeaway here, I think this is it. Really should be thinking about things in terms of invariance when you're writing a protocol. And then if you've done that, then there's two kind of high level strategies, I think, for getting at these invariants. So one is to use formal verification, prove what you can, write them in something like Sartora verification language. You might be able to prove them exhaustively over your entire space, which is awesome when it works. But sometimes it doesn't work. You need to make approximations in those to make the problem tractable. And so there, you have to do what you can, and then for whatever you can't do, try to come up with other ways of testing those things. But even if you can't prove certain things, it's a really super beneficial exercise in itself. Also, Kurt mentioned this, but just the act alone of writing these invariants causes you to think differently about your problem in a different way, in like a more top-down way instead of a bottom-up way, and that is really valuable to give you insight into other. Yeah, sure. Looks like I have 5 minutes left. Is that true? Yeah. Okay.
I'm just like, you have like 50%
Yeah, I mean, I've got way too many slides here. I'll just jump through the end here. But yeah, I mean, this is really what I want to focus on. Actually, is the invariance and the strategies for proving invariance and working through scenarios. So scenarios for everything else. For Compound 3, we built a new scenario framework which lets you kind of write properties, and I'll just skip to an example here. So when I talk about scenario, there's like a property, there's assumptions that you make, and then we have a framework that lets you generate different worlds and contexts in which those assumptions that you've written down hold, and then you can test this property in all of those different situations. So this is kind of like an example output where we take our scenario suite for Compound 3 and we run it, and it runs on forks of deployments on 4 different chains that we have. And so you're running your scenario suite against lots of different variations of different forks. I can talk more about this. There's probably a lot to go into here more than I can cover. So I guess I'll move right along. Mentioned already, but you should get more eyes on your code. Hire auditors, triple, quadruple check your work. Share it with the community. Share your ideas. Share your spec. The more people understand your spec and your intention, the better feedback you'll get. Another tip is just like, don't take feedback personally when you're doing this, because you really want to get as many criticisms of what you're doing and find as many holes and things as you can. And the sooner you discover issues, like the better. So be grateful when people take the time to help you and look at your code and your spec, and whether they find issues or not, just be glad that they did that. I'll also take the moment to thank the people that helped us do that for Compound 3. So Chain Security, Shora, Open Zeppelin, Gauntlet. I think people from all those companies are here. So thank you for all your help with Compound 3. You guys are awesome. And then the last step is kind of shipping your code. There's also kind of a lot to say about this probably, but I'll just say that for V2 Compound, there was we went from a centralized like a company deploying the contracts and having a multi-sig key to control them, to a DAO controlling those things in a time lock and taking like a week to at least to upgrade things. And the design of V2 didn't really, it was kind of it was just very organic and didn't really think about the how to best do that. With Compound 3, we've kind of thought a lot about how to make the code maintainable by a DAO. So it's really a more holistic approach. Our strategy now is really to have like a deployment script for each network or deployment that the code is on. And there's some relations that can be kind of crawled automatically so that you always know what the set of contracts for that deployment are. I'll talk more about that if you have questions. But the other part of this is planning for evolution. So how do you change the code once you've deployed it? And the simple story here is for Compound 3, we've gotten it down to like you open a pull request, you can see if that our scenario suite and all our tests run against that pull request and the hypothetical changes that are being made in it. You can see the artifacts being generated. You can also actually do the same deploy from the same scripts that's being tested in GitHub. You can do the real deploy, and it makes it easy for governance to review those things. And once it's executed, you can merge the PR. So I think I'm out of time, but thanks. If you have questions, I'll be around. Also, I'm on Twitter at jmflatow. You can join our Compound Discord, and also, if you're interested in this stuff, we are hiring, and happy to talk to you about that as well. But thanks.